we are going to use the definition of Taylor series to find the first four non-zero terms of the series f of x equals natural log of x centered at a equals 1. Now I'm going to change this up a little bit. I'm going to drop f of x equals natural log of x down one line. I have my reasons. You'll see them in a minute. F prime of x, we need to start taking derivatives because this says use the definition. And f prime of x is equal to 1 over x. Second derivative, f double prime of x is, well, we're going to use the power rule. This is x to the negative 1, isn't it? So this is going to be negative 1 over x squared. The third derivative of f is 2 over x cubed. Now, how many of these do we need to do? We were told to find the first four non-zero terms of the series. Let's start evaluating these at a, which is 1. F of 1 is equal to the natural log of 1, 0. Shoot, that one's 0. We don't get to include that one. F prime of 1, 1 over x, well, that's going to be 1. F double prime of 1 is equal to negative 1 over x squared, so negative 1. F triple prime of 1 is equal to, well, 2 over x cubed, that's going to be 2. We don't have four coefficients that are non-zero, so we need to take a fourth derivative. The derivative of 2 over x cubed is going to be negative 6 over x to the fourth. And so we have that the fourth derivative evaluated at 1 is, well, it's negative 6 over x to the fourth, and so negative 6. Now, a little bit of notation here. We're finding the first four non-zero terms, and that means that we're dealing with like an nth degree Taylor polynomial. We're looking for t sub n. I'll just write that down as t sub n of x, and then we'll come back to that maybe in a bit. So this is the one where when we write down the sigma notation, it's going to go, like I is going to go from some number to infinity, right? So for the 0th derivative, we have that I is equal to 0. For the first derivative, I is equal to 1, I is 2 for the second derivative, I is 3 for the third derivative, and I is 4 for the fourth derivative. So we are looking for something where I ends up at 4, and we aren't including I equals 0. So our sigma notation is going to start with I equals 1. And remember, what we're looking at is something of the form, the sum as I goes from 1 to 4, right? Because we have four non-zero terms, of c sub I times x minus a to the I, where the c sub i's are the ith derivative evaluated at a divided by I factorial. Now in this case, starting at I equals 1, we have 1 over 1 factorial. That's 1 from f prime of 1 equals 1, and then 1 factorial because I equals 1, times x minus 1 to the first power. Let me make sure that looks like a 1 and not a derivative. Of course, we're not going to write that in our final answer. Minus 1 over 2 factorial times x minus 1, the quantity squared, plus 2 over 3 factorial times x minus 1, the quantity cubed. We're using these coefficients that we got from the derivatives, divided by I factorial times x minus 1 to the I. Minus 6 over 4 factorial times x minus 1 to the fourth power. Notice that the largest degree on x is a 4. Now we can go back here and say, hey, what we're finding is actually the fourth degree Taylor polynomial. And so I'll write down that t sub 4 of x, because that's really what we found, is equal to, after we simplify, x minus 1, I'm writing that in parentheses so it looks like it's just one term there, minus 1/2 times the quantity of x minus 1 squared, plus 1/3 times the quantity of x minus 1 cubed when we simplify 2 over 3 factorial. And then the next term is going to have a coefficient negative 1/4, and we've got x minus 1 to the fourth power. That represents the first four terms of this power series expansion.